30 questions here. Engine performance 2, test 13 and 14. We can just jump right in here. Everybody needs to be able to, let me tell you, when we go into our final exam stuff, you need to be able to verbally explain the 4-stroke cycle to me. I don't care if you get it off YouTube. I don't care if you get it out of your textbook. I don't care where you get it, but I have a few questions out of the top of your head with no notes. You need to be able to explain things to me, right? Got it? List, define, explain is part of it. Being able to do the work and figure out what's wrong is good too, right? As the load on an engine increases, manifold vacuum decreases, and the manifold absolute pressure does what?
Okay.
You know a difference between manifold vacuum and manifold absolute pressure? If you add them together, you get barometric pressure. Got it? If you add manifold absolute pressure and manifold vacuum, you know, basically, if your vacuum is 18 inches, what's your pressure going to be? What's manifold absolute pressure as far as, what's if you pull every bit of the air, like on your air conditioning machine out there, if you pull every bit of the air out of the system, what's your gauge reading?
0.
Excuse me for the sneeze, 30. So you're going to take 30, which is going to be as much vacuum as you can get, right? Okay, so you've got, if you pull 18 inches of vacuum, you've got 12, right? So 18 and 12 would be 30. So basically B is going to be the answer here. Manifold absolute pressure is going to be whatever is, you know, when you subtract manifold absolute pressure from 30, you're going to get, when you subtract manifold vacuum from 30, you're going to get manifold absolute pressure, as typically. And you're going to see some scan tools are going to actually be talking about vacuum now instead of manifold absolute pressure. They used to just use manifold absolute pressure, and that was vacuum. And now they've sort of changed that up. Engineers got involved, I guess. So that's going to be a B there. And what is she calling me back for? Hang on just a minute. Yeah, Sonia, what's up?
Hey, those 2 vehicles that you're getting rid of,
Yeah.
can you drain all the fluids out of them?
Yeah, I can do that.
When you get finished?
Yeah, I can make that happen.
And Darby brought the keys to that police car, so I've got them
Okay.
down here.
Yeah, that's the only set of those I got, yeah. Yeah, he'll even get that back to me. We'll get the fluids out of them. That's all right. We got to get all the fluids out of the 2 cars I'm getting rid of. Just drain them, you know. So a typical MAP compares the vacuum in the intake manifold to, what was I just saying? What's perfect vacuum is 30 inches. Can't you have more than 30 inches of vacuum because that's all there is? So it's going to be perfect vacuum. It's going to compare it to that. Which statement is false? A, absolute pressure is equal to barometric pressure plus intake manifold vacuum. B, the MAP sensor compares manifold vacuum to perfect vacuum. C, a decrease in manifold vacuum means an increase in manifold pressure. D, barometric pressure minus the MAP sensor reading equals intake manifold vacuum.
A.
And B, A was the one that's wrong. Okay. Which design of MAP sensor produces a frequency digital output signal? A, ceramic disc, B, piezoresistivity, C, silicon diaphragm strain gauge, or D, capacitor capsule?
B.
That's going to be the D. That's the one like the Fords have on them, which the ones that have it, like the Broncos, have got a 160 hertz at sea level. Whenever you first turn the key on, you crank it up, it drops to 110 because it's got a vacuum hose hooked to it. So it basically gets barometric pressure reading from that same sensor when you first turn on the key, because barometric pressure is what's in the manifold when the engine's not running, right? When the engine's running, throttle plate's closed, engine, you know, the pistons are lowering the pressure in there to try to draw air in. You're basically going to have low pressure in there, and it reads that, and that tells about engine load. Okay, which of these is not a purpose of the or function of the MAP sensor? That's number 5. Does it help diagnose the EGR system? Does it measure engine speed? Does it measure load on the engine? Does it calculate fuel delivery based on altitude?
A.
Actually, it does help diagnose the EGR system. The way it does that is whenever the EGR is flowing, vacuum drops. You know, in other words, the pressure in the manifold changes when EGR starts flowing. So yes, it does do that. It cannot measure engine speed. There's no way. But it can help diagnose the EGR system. And as a matter of fact, it's the feedback device on some systems, or a feedback device.
I figured it would be able to measure the engine speed based on the load on the engine.
Well, not really, because by itself, all it can do is measure pressure, and these other three, these other three criteria are pressure related. But measuring engine speed is basically going to be something that you're going to have to be seeing a crank sensor looking at a tooth wheel. When measuring the output signal of a MAP sensor in a General Motors vehicle, the digital multimeter should be set to read what? Believe it or not, it's DC volts. Frequency in hertz is what you're going to measure on the Ford, right? Two technicians are discussing testing MAP sensors. Technician A says the MAP sensor voltage on a General Motors vehicle at idle should be about 1 volt. Technician B says the MAP sensor frequency on a Ford vehicle at idle should be about 105 to 108 hertz. Who's correct about that? Well, both of those guys are right. I never liked 105 to 108. It seems a little low to me. I usually see about 110. But whatever, whoever wrote the book likes it that way. Technician A says MAP sensors use a 5 volt reference voltage from the PCM. Technician B says the MAP sensor voltage will be higher at idle at high altitudes compared when the engine is operating at near sea level. That's a C. Both those guys are right. Now, I talked about this before. If you ever drive a car with a carburetor on the old school stuff at a really high altitude, it won't hardly pull your hat off. It's terrible unless you advance the timing and whatnot. A MAP sensor being tested. Technician A says many MAP sensors act as a barometric pressure sensor when the ignition switch is turned off. My phone will not leave me alone. What you got, Judy?
Would you agree to have lunch company?
Oh, absolutely. I would be more than happy to. You want me to swing by there and get you whenever I go get Alan?
Yeah.
All right, we'll do it.
All right,
Technician B says on many MAP sensors, the signal voltage should increase when the vacuum at the sensor decreases. Okay. They act as a barometric pressure sensor. I just talked about that, right? Also at wide open throttle. When it knows you're at wide open throttle and you pretty much got atmospheric pressure in the manifold, it will update. Think about this. What if you started out driving here and then you drove until you were at a high altitude? And that's possible in some areas where you could start pretty close to sea level or down, and then go up at high altitude. It needs to update every now and then, doesn't it? Because you don't have to switch it off and restart it just because it starts running crummy. But as you're going deep into it, it's going to update. But, so, let's see, what number was that I was on? Number 12? 10. Oh, 10, I'm sorry. Technician B says manifold absolute pressure sensor uses perfect vacuum zero.
Sorry, it was 9 actually.
Yeah, okay. Yeah. Technician B says on many MAP sensors, the signal voltage should increase when the vacuum at the sensor decreases. What do you think about that? That's B, right? Well, that said, when the ignition switch is turned off is where the killer is on that first part of that question. When the engine is on, when the key's on but the engine's off, it measures it. But when the ignition switch is turned off, everything goes dark. Technician A says a heavy engine load results in high intake manifold vacuum and a high MAP sensor signal voltage. Technician B says a manifold absolute pressure sensor uses perfect vacuum, which would be zero absolute pressure in the sensor to determine the pressure. Which technician is correct? B? Huh? Who's at the door?
Quincy.
Oh, where's Quincy? Go get Quincy. Tell him to come on in here. What's holding Quincy up? Quincy, get in here. All right. All right, right here. Come on in here, Quincy. What are you trying to sneak around out there for? I thought you were sneaking. Your alternator's sitting right there. All right. Okay, let me see. The output of a MAP sensor reading is 1 volt. What's the approximate engine vacuum in inches of mercury? Give me if it's 1 volt, what's the approximate engine vacuum in inches of mercury? Who knows?
Or 5?
Actually, what's normal engine vacuum when you're sitting there idling on a healthy engine?
Something.
17 to 21. That's what you're looking at there.
What was 10? B.
Oh, yeah, that's a B.
So 11 is 17 to 21.
Well, yeah. What's that now? Yeah, 17 to 21 is right after 11. So you're looking for about that much when you got a healthy engine idling there. Two technicians are discussing MAP sensors. There's a lot of that going on in this test. Technician A says MAP sensors should be replaced if anything comes out of the sensor when the vacuum hose is removed. If you pull the vacuum hose off and jelly or something comes out of it, you need to put a sensor on it. Technician B says the injector pulse width should increase when vacuum to the MAP sensor is increased. What do you think? That's a little backwards, isn't it? If you reduce the vacuum to the MAP sensor, it means you get more of a load, and you should have more injector pulse because you need more fuel, correct? Technician, a P106 diagnostic trouble code is being discussed. Technician A says a damaged or missing MAP sensor O-ring could be the cause. Technician B says a defective MAP sensor could be the cause. Now the reason I'm saying O-ring, a lot of these MAP sensors now are bolted right to the manifold. Like on the little Neon and these Chevrolets and these GM cars, a lot of them are just bolted right to the manifold. And if you got an O-ring that's missing or damaged or something like that, you're not going to have a good strong vacuum there. It's going to be hissing past it, isn't it? That's going to be a C. Number 14, a P0108 diagnostic trouble code is being discussed. Technician A says a damaged or missing MAP sensor O-ring. This is the one I was just talking about. Could be the cause shorted to ground. Could a signal circuit be shorted to ground? Which one would be right about that? Hey, these trouble codes, unless you've got the trouble codes memorized and you know what they're talking about, these trouble code questions are sort of, subjective, A scan tool can be used to test a MAP sensor by monitoring the injector pulse in milliseconds while what is applied to the MAP sensor?
Voltage.
I'm going to basically have all my wires plugged in already. So,
Ground.
no.
Is it deep?
Is vacuum. You're pulling vacuum on the MAP sensor right there. Okay. All right, let's do this. Got to keep setting my camera here because I'm cutting off half my face there. Let me see here. Fuel injection system that does not use a sensor to measure the amount of mass or mass of air entering the engine is called. We've asked this question before.
Is it airplane controlled?
No, it's actually, believe it or not, it's speed density. A speed density system is the one that only uses a MAP sensor. Which sensor has a switch that controls the electric fuel pump? That's the one, the vane airflow meter. The vane airflow meter is kind of like a throttle position sensor, but it's got an L-shaped flapper that moves when the air goes past it, and it's hooked to a potentiometer. And it's also got a little reed switch in it that operates the fuel pump relay. As soon as you start spinning it over and it starts moving that little vane, it lets that reed switch close and your fuel pump works. That's how that operates. Vane airflow is the only one that has that though. Two technicians are discussing Karman vortex sensors. Technician A says they control a burn-off circuit to keep them clean, contain a burn-off circuit. Technician B says they contain a movable vane. Who's right about that? Both of those guys are bozos. They don't know what to talk about. That's going to be the vane airflow. Those vane airflow sensors, the last time I priced one, we were working on a Toyota MR2 that had one on it, and that thing was not reading like it was supposed to according to the specs I had, but a replacement sensor was like $800. And I decided, I think I'm going to look for the problem somewhere else before I condemn that thing. And sure enough, I found a problem somewhere else. It's really scary when you're looking at a sensor that's expensive and you're not sure that's what's wrong, And sometimes we find ourselves in that position. The typical mass airflow reading on a scan tool with the engine at idle speed, normal operating temperature, and that's mass airflow now, is what are you typically looking for there?
3 to 7 grams.
3 to 7 grams per second. And you'll be surprised how much that'll change based on engine coolant temperature. When you got more idle air control, you can turn on the air conditioner and it'll open the idle air control a little more and it'll change that grams per second reading. And it's really, it bounces around in there. Two technicians are diagnosing a poorly running engine with no stored diagnostic trouble codes. When the mass airflow sensor is unplugged, the engine runs better. Technician A says this means the mass airflow is supplying incorrect airflow information to the PCM. Technician B says this indicates the PCM is defective. Which technician is correct?
A.
That's A. Which airflow sensor has a dampening chamber?
Karman vortex, right?
That'd be the vane airflow, believe it or not. The Karman vortex has got a couple of speakers. You ever noticed, have you ever been in a situation, Adam, where, like if I had a speaker on that wall over there and it was talking to me and somebody could blow a really strong wind through this room, you wouldn't hear that speaker, would you?
I mean,
It'd blow the sound away. And that's the way these little Karman vortex sensors have got a speaker on one side and a little listener on the other side, and the more air there is blowing through there, the more that sound is distorted. And that's how they tell. And those are typically found on some of your older Mitsubishi things and all that. That's like a $600 or $700 sensor last time I priced one. I've seen mass airflow sensors cost as much as $1,200. I've seen them cost as little as 75 bucks, depending on what kind of vehicle they're on. P0102 diagnostic trouble code is being discussed. Technician A says a sensor circuit shorted to ground can be the cause. Technician B says an open sensor voltage supply circuit could be the cause. Yeah, that's another one of those code questions. That's going to be C. Both of them can be right. Now everybody knows how mass airflow sensor, the hot wire one, works. It's got a cold wire and a hot wire. It's looking at the temperature of both wires. The cold wire tells it what the ambient temperature of the incoming air is, right? What it's going to do is it's going to apply current to that hot wire to keep it at some, the benchmark is the cold one, but it wants to keep it at 300 degrees Celsius above that cold wire. And so the amount of current it has to apply to do that tells it how much air is going through there. See, it's measuring temperature at the same time, but it's got to factor that in. That sensor is a pretty smart sensor, to tell you the truth. Well, what happens whenever somebody's got an air filter that has, you ever seen an air filter, have you ever pulled an air filter out of an engine that's been compromised and had holes in it actually? You just pull the air filter out and it's actually it's rotted to the point where there's holes in it. When you got holes in the air filter, you're going to have crud packed against the mass airflow sensor, and it's got a little platinum wire wrapped around this high temperature plastic. And that platinum wire is so tiny that you have to look at it with a real strong magnifier to even see it. Well, if it gets coated with junk, then it's not going to react as fast as it should, and that's going to skew those. This guy came in on an '89 Mustang one day, which is the first time Ford started putting mass airflow on there. And it didn't have OBD2 or anything, but he said, this thing runs terrible. He said, it won't hardly pull your hat off. So I pulled it out of there, looked at the mass airflow sensor, it had dirt and crud all over it. I washed it off with some cleaner, put it back in, the car ran like a race car. Sometimes it's as simple as just cleaning the mass airflow sensor will make them run a whole lot better. That's a big deal. I'll tell you something else. When I had that Ranger set up, I used to do a test on that Ranger, and this is really important, so pay attention. Looking at the voltage on the Ranger, when it's idling, fuel trims would be beautiful, just like they're supposed to be. That voltage on that sensor would be like 0.81, 810 millivolts on that sensor, engine idling, warm engine, all that kind of stuff. I had another mass airflow sensor that was faulty that I could put on there that would drop that voltage to 790. It would go from 810 to 790, very small amount. That's a tiny few millivolts. But it would cause those fuel trims, because it was reading just a little lower than what was accurate, the fuel trims would count all the way up, I'll be there in a minute, would count all the way up to way up high, you know. I mean, like 25 or something like that. So be aware of that thing. That's the annoying thing about a MAP sensor to me. Sometimes the MAP sensor can be just a tiny little bit off and cause your fuel trims to go crazy. And it's real sensitive. Okay, let me see here. Technician A says the mass airflow sensor actually measures the density and amount of air flowing into the engine. Technician B says a hot wire mass airflow sensor uses the electronics in the sensor itself to heat a wire 70 degrees Celsius above the air temperature entering the engine. And see, every time I've ever read a number on how much it heats that wire, it's a different number. I've heard it was 400 and something degrees. I've heard it was 300 degrees Celsius. Now I'm seeing it 70 degrees. I don't know if it's the same or different number sensor, but I tell you what, it doesn't matter. Because you're not measuring that temperature. The sensor is actually the one that's providing that. So yeah, 23, both those guys are right. Technician A says a mass airflow sensor is a high authority sensor and is responsible for determining fuel needs in the engine based on the measured amount of air engine. It is a really important, that is absolutely true. Technician B says a cold wire mass airflow sensor uses, that's the hogwash answer, ignore him. It's a, what are the two methods of sensing incoming airflow? Incoming airflow can be sensed how? Either what?
Let's see. Or no, wait.
Speed, density, and mass airflow. Basically, yeah. You can't do it with EGR and positive crankcase ventilation. You can't do it with mass airflow and air intake. You can't do it with speed, density, and throttle position. Okay, number P0103. Technician A says a sensor circuit shorted to ground can be the cause, and that's another code question. Technician B says a defective mass airflow sensor could be the cause. Which technician is correct? And that's going to be B. All right. You guys remember this. You're going to have to spit them out. Number P0100 DTC as being discussed. Technician A says an opener or short and the mass airflow circuit could be the cause. I hate these code questions because I don't have the codes memorized, right? Technician B says a defective mass airflow sensor could be the cause. And just that's a C. And we got 3 more questions left. Which of the following can be used to measure the frequency and output of the sensor and measure the reading within specs? What can you use? Can you use a megometer, logic probe, high impedance test light, or a digital multimeter? You gotta put a digital multimeter on there. You will not read that frequency without it. And you gotta have one that'll read frequency. Just any meter won't read frequency. If it doesn't have hertz, you can't do it. A vehicle runs fine when in reverse, yet has rough idle installs when put into drive. That could be caused by what?
Excessive fuel pressure.
How about a cracked air inlet hose? Think about that. Think the air inlet hose, you got air flowing through that hose, it's being measured by the sensor. Whenever you put it in gear, it's got a crack, it opens up. Now a bunch of air is coming in, the sensor's not measuring. Got me? That's unmetered air, okay? The component, and I've seen that garbage. You know, where you go to put it in gear and it do this. It would go, because when it would lose power, it closes that crack up. Then it gets power back and opens the crack back up and it goes into a cyclic thing. The component shown, which is shaded, has a crack in it. That's what we were just talking about, right? And that's going to be C. Everybody happy with that test? I think you did okay on it.
What was 12 and 14?
12 and 14.
Talk to him, guys.